let's review all of the acronyms and words and things that we've been talking about here in Unit 2. So first of all, let's just start off with protocol. Or maybe not. There we go. What is a protocol?
Well-known set of rules.
Well-known set of rules. If it's not well-known, it is not a protocol. Remember the story we talked about the old dude in Walmart yelling at us about putting our carts outside? That was not a protocol because nobody knew about it. That was just a secret rule. I don't know what you would call it. But it's not a protocol unless everybody knows about it and understands what's going on. So make sure when you define protocol that it's a well-known set of rules. So now let's talk about some different protocols that we use. The TCP, remember what that one is? Yep. Transmission Control Protocol. Which is just the rules for setting up something so that you can send out a request or a piece of information or whatever it is, or setting it all back up when you get something. If you get a home page, if you get a picture sent to you, the rules for setting it all up so that it can be reconstructed from all the little packets that it's set up with, okay? And so right along with that, we want to talk about HTTP, which we don't have to usually type anymore. You used to have to type HTTP, www dot whatever, right? We don't have to do that anymore. So this is the transmission, or excuse me, the hypertext transmission protocol or rules. So hypertext is the language we use to write web pages. So hypertext transmission protocol is just how we send those web pages from a server through the routers to wherever it needs to go. Okay?
Isn't it hypertext transfer protocol?
Oh, did I put transmission instead of transfer?
Yeah.
Excuse me. I'm still had transmission on. Transfer. I still had transmission on the brain. Transfer protocol. And why we're talking about that, we better talk about HTML, which is hypertext. Yep. Oh, markup's one word. Hypertext markup language, which is what we use to write web pages generally. It's what sets up the web page and sets all the text to go in the right place, and align left, align right, this part's blue, put the picture here. There's also another one called CSS that we use to make the web page prettier. Just get out a piece of paper and you want to take these notes. But HTML is pretty much what we're doing. Here we got some. Okay. Now, along with this, I want to talk about HTTPS, which is still hypertext transfer protocol, but it's secure. It's on a secure line. When you see that, well, a lot of times it doesn't say HTTPS anymore up in the bar, but you will see a lock that is locked. That means any information you send on that to that website and back and forth is going to be secure. or as secure as it can be on the internet. Don't ever send any information about yourself, your email address, your name, for heaven's sakes, not your credit card number, to any website when you are not on a secure link. Got it? Okay, so if you see just HTTP, that link, it looks like this. See how it's open? The padlock's open. That means we're not gonna send anything that's sensitive back and forth across that link. Everyone understand? Okay, so you have the HTTP and then the HTTPS. It doesn't really need to be a secure link if all you're doing is getting a web page or something. A lot of times it is anyway, especially on bigger things, but that'll work. Okay, IP address. What's the IP stand for? Huh? Internet Protocol. Address. And each device has one. Every single device that's on the World Wide Web has its own individual IP address. And it has to be that way, just like every house has to have an address, every government building has to have an address, every school has to have an address. You can't send something there or even receive something from it if it doesn't have an address. It's got to work that way. Along with that, we talked about DNS. Remember what that stands for? Lots of acronyms. Domain Name System. Now, the domain name system is scalable. What does scalable mean? As there gets to be more and more domain names, is the internet okay with that?
Yeah, it is.
Are we going to have a domain name for every single thing possible?
Yeah.
Really? www. You're going to come up with something for everything? So remember, a domain name is just tied to an IP address. So if I type in espn.com, my computer doesn't go out looking for espn.com. It goes out looking for the IP address that is attached to that. So the computer's doing it all by the IP address, not by the actual name of the website. For us humans, it makes a lot of sense to say code.org, not, what was it, 114.47.86.113? That doesn't work so well for us, does it? Okay, code.org, we're good with that. And then that's tied to an IP address. Remember, domain name system, IPv4. You guys remember how many different IP addresses that has?
4 billion.
4 billion. Not enough. Not enough IP addresses for all of the devices that are going to be on the internet soon. Okay, so now we have gone to IPv6, and IPv6 has what?
We don't.
Like 900 billion?
It wasn't an undecillion?
Yeah,
It's huge. Like way more than
That was enough IP addresses for every single grain of sand on the earth to have its own IP address. So that's pretty much enough for all the computer devices on the earth that will ever possibly be here, and probably any other world where there's aliens that have devices as well. That's a lot of IP addresses. You don't have to remember the 4 billion and the undecillion. Just know that there's a lot of IP addresses, and we're good to go. Part of the domain name system was the .com, .org, .gov, .edu, kind of breaking it up to make it a little bit quicker for your router to find where it's going. So if you're looking for something that's .com rather than .gov, then it knows which servers to go to, and the router, it makes it easier for the router to find it and all that stuff. So .com, what type of websites are going to use .com?
Companies.
Company. Okay. What about .org? Organization. That would be churches, nonprofit organizations, Girl Scouts.
Code.org.
Yeah, code.org, nonprofit organization. There you go. Gov, obviously government. Edu, education.
Why don't we use that edu?
I don't know why. Like my email, for example, is courtesy@emeryschools.org. Maybe we should ask someone who might know that.
I think it's because it's .edu is like easier to like change and hack into than .org. So like edu is like accessible to like everybody, so it's like Wikipedia, and then .org is just like a specific organization only they can access.
Could be. I noticed that the .edu is everything higher education, so college stuff is always .edu. I'm not really sure about that. I've wondered about it before, but I don't know the answer to that question. That's a good question. Okay, routers. There are, I don't know the number of routers, a bejewel of routers out there. And the more routers there are, the more pathways there are to get to where you're going. And so as the internet grows, it actually, rather than getting more complicated and harder to use, it gets easier to use because there's more pathways for your packets to take to get to the server that is serving up the web page that you might be looking for, or the Google image that you're looking for, or whatever it happens to be. Through a GET request. Get me code.org login page, please. So when you type in code.org and hit enter, that's what you're sending out as a GET request for their homepage or their login page. And your computer's sending it to the router, which finds the server that serves up that particular web page, and then that's being sent back to you in a bunch of little packets of information rather than one ginormous thing. So remember, a picture could be, a high definition picture could be a billion ones and zeros. Okay? That's difficult to send all at once. So rather than send out the whole picture or the whole web page or whatever, we're going to break the web page, we're going to break the picture up into hundreds or thousands of little pieces called packets, and we're going to send them to the router individually. Okay, so these are packets, and those are all going to get sent over different pathways through different routers somehow to you, right? And then your computer is going to use the transmission control protocol to put it all back together and make it work. Making sense so far?
Yeah.
Okay. So, when you get a web page, let's talk about what that web page is made up of. What things are you going to get when you get a web page? What different things are there? The name. Okay. What else? Say it louder. The link to it, okay. So I get the link, type in the link, I hit enter. What comes to me? Say it louder. The text. The text comes. The written words, right? How do all those words know where to go and where to align and what color to be and where the paragraph breaks are? And how's it know all that stuff? I'm going to get a computer program, HTML, and that's probably the first thing I'm going to get, or the first thing that I actually load up on my computer, and that loads up the basic framework of the web page. Okay, text here, pictures here, links here, color, all that stuff. Okay, then all your text is going to fill in. Hello. Yeah, he did. Yeah. Okay, thanks. Breezy said you just got a tardy. Yeah, I don't know. I never had marked it because you came in late, so we'll look at it. Anyway, text next. Then probably I don't know what else you're gonna get with a web page.
Images.
Say it louder.
Images.
Images. Pictures. Can I just put that? Okay, your pictures are going to fill in, and probably the links. There's lots of links on a web page, right? That kind of stuff. And I don't know, probably, I don't know which one of those would be next, but first of all, the HTML is going to, that program is going to set up the framework, and then it'll put in all your text. And have you ever watched a web page load slowly, where it loads, you know, a little bit at a time, and that's kind of what you can see going on. Redundancy. I still don't think you guys comprehend redundancy. If I'm up here teaching a lesson and there's another teacher just walking around doing nothing, that other teacher would be redundant. If I say, you all need to be to class on time, you all need to be here before the bell rings and sit down, you all need to be here when you're supposed to be, do I need to say all three of those things? No. Do you understand redundant? Okay. If I send out 3 copies of an image to somebody through 3 different routers, and eventually they go all over to a million different routers, and eventually they come to the correct place, and 2 of them are nice pretty copies and one of them is crappy, broken up a little bit. Do you see the redundancy there? Do we need to get 2 good copies and 1 crappy copy? No. But what happens if we get 3 crappy copies? Can we put them all together and make 1 good one?
Yeah.
Yes. So this is the idea with redundancy, is simply kind of like a backup or something. It's great in theory because you're sending it out and making sure that they get it. It'd probably be hard to deal with if you're on the other end getting it all and trying to put it all together, right? So, for example, let's say you're in the military and you have to put up a tent. So you get this truck pulls up and it's got 3 times more poles than you need, 3 times more rope than you need, and 3 times more pegs than you need to go on the ground.
Then you can go 3 times.
Not really, because it only has 1 tent. But you have no instructions. Are you going to try to use all the poles and all the rope? Probably. Is that going to work very well? But what if you have a set of instructions telling you how to put the tent together, and you go, oh yeah, we don't need this set of poles, we just need the one. Right? You have a protocol. You can make it happen. You can make it work. So I don't know if that's a good example, but I hope so. I hope that helps. So, on part 7, Internet Dilemmas Part 1. Did you guys read through the thing, and did you pick a dilemma? Did you choose one of the dilemmas?
Net neutrality?
You what?
Is net neutrality one of them?
Yeah.
Yeah, there were 3 of them. Net neutrality. You remember the other 2?
One was about speech, hate speech.
Free speech. Okay. Was there one more?
I think there was, but I can't remember.
All right. Well, so you can choose one of those. If you'd like to choose a different thing on the internet that's kind of a deal right now, just talk to me about it. We can make that happen. You need to be reading the articles that are provided to help you make a decision about things. You need to be looking at the videos there in the articles, and you need to be taking notes about what you read and what you're going to do to fill that thing out. And I want a copy of your notes. You understand? So make sure that I have your notes that you take as you read through the articles and watch the videos. And then you're going to fill out that activity guide and make some decisions about what you're going to tell the candidate running for office and what you think a good policy would be. As you get to number 8, lesson 8, you're going to answer that question: has the internet made the world a better place or a worse place? You can use those same articles or videos, but other articles and videos that you may find in order to make your decision about that. There is no correct answer. Whatever answer you want to give, as long as you back it up. Okay? So I want a 4-paragraph essay. So kind of intro, or did I say 5? Intro, and then maybe 3 paragraphs about your reasoning, and then 5 paragraphs, and then kind of wrap it up, kind of thing. Have you written essays like this before?
Yeah, isn't it like
Okay, that's pretty much what I want. So I want the 5-paragraph essay, and I want you to cite sources.
Spelled site wrong. With a C.
Yeah.
I don't care. I make those mistakes all the time. Just thought it's kind of funny.
You know what? If it's not Pythagorean, I can't spell it. I can spell anything math related. Okay. I spell it like a website
Euclidean.
instead of, yeah, I can spell that. So anyway, make sure you cite your sources. So, and I'd like you to have 3 of those at least, minimum 3 when you do that. So I would say we spent 1 day working on lesson 7 so far, haven't we? I would expect you to get that finished. When do we have class again? Tuesday? We have class again on Tuesday. I would expect that to be done on Tuesday. And then the essay is going to be due on Thursday.
Is our grade set right now? Pretty much?
So what?
Is our grade set right now pretty much then?
Yeah, grades are done for this term. Yeah. Yep. Okay. All right. Let's go.